Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome to the next edition of our online class coming to you from Islamic College Oshogbo. This is chemistry for SS2 students. Today, inshallah, we are going to start our discussion on another non-metal, which is carbon in this case. Carbon, like you are aware, is a group 4 element having 6 electrons in its atom, with having electronic configuration of 2 4 or 1s2 2s2 2p2. Therefore it exhibits tetravalency, that is a valency of 4, meaning that each carbon atom can form 4 bonds with other atom. Carbon exists in different forms in nature. Like it exists as diamond, it exists as graphite, it exists in combined form in marble, in chalk, in calcite, in dolomite as calcium tricarbonate 4, as well as magnesium trioxocarbonate 4. Carbon is a major constituent of all living organisms, or all organic matter, as you may like to say it, and it is a major constituent of most food substances that we eat. It's an element that exhibits allotropy, and the different forms of carbon is as shown in the table or the chart that you can see on your screen. Carbon can exist as crystalline form. It can also exist as amorphous form or non-crystalline form. The crystalline allotropes of carbon are of 2 different types: diamond and graphite. The non-crystalline form can be classified into 3. We have coal, we have charcoal, and we have lamp black or soot. Coal can be subdivided into 3 forms or 4 sometimes. We have peat, lignite, bituminous coal, which is also called soft coal, and hard coal, which is also called anthracite. Charcoal can be plant charcoal or animal charcoal. Plant charcoal can either be sugar charcoal or wood charcoal. These are the different forms in which carbon exists in nature, or in which carbon can be transformed into. Now, taking the allotropes one after the other. The first one we are going to look at is diamond. Diamond is a giant molecule. In diamond, each carbon atom is covalently bonded to 4 other carbon atoms, meaning that all the 4 valence electrons are used in bonding. Therefore, there is no free or mobile electron. Look at the structure of carbon as shown here. In diamond, the carbon atom at the middle is bonded to 4 other carbon atoms, and each of the 4 other carbon atoms is bonded to 4 other carbon atoms. Each is bonded to 4 other carbon atoms, and so on and so on, until we have a very giant molecule as we have it below. And there is no free electron at the end of the day. Diamond is the purest form of naturally occurring carbon. It is colorless, lusterless, but can be formed into brilliant gems. It is octahedral in shape. Now, what are the uses of diamond? Before we go to its uses, let's look at its properties. Diamond is the hardest known substance, and that will inform us of its use, the most famous use of diamond. It is very dense, with a density of 3.5 gram per cubic centimeter, and it is resistant to temperature and chemical attack. It does not conduct heat or electricity. Definitely it cannot conduct electricity because there is no free mobile electron. You all will remember that what makes a substance to conduct electricity is the presence of mobile electron or free ions. So you can only talk of free ions when you are talking about compounds, electrophilant compounds. But to talk about mobile electrons when you are talking about elements. Now we are talking about elements, carbon. So an element will only conduct electricity when it has mobile electrons. Since all the electrons are used in bonding, diamond cannot conduct electricity. And it is not soluble in any solvents. It is insoluble in every known solvent. Now, what are the use of diamond? It is used as abrasive to sharpen very hard tools. And this is because it is dense and hard. Those instruments they use in sharpening cutlasses and knives are made from diamond. Since nothing can cut diamond apart from diamond, it's also used as glass cutter because of its hardness. It is used as pivot for precision instruments like balance, beam balance, or letter balance, or chemical balance. This is because it is hard and does not flake. And it's also used in making jewelries solely because it has high refractive index. Now to the other allotrope of carbon, the other crystalline allotrope of carbon, which is graphite. Graphite occurs naturally as black, slippery, hexagonal crystal. And in graphite, the atoms of carbon are arranged in layers. At each layer, each carbon atom is bonded to 3 other carbon atoms, as you will see in the next slide. This is carbon atom bonded to 3 other carbon atoms. Another carbon atom bonded to 3 other carbon atoms. Another carbon atom bonded to 3 other carbon atoms. In such a way that for each carbon atom, only 3 of the valence electrons are used in bonding. 1 of the valence electrons is free. And this free electron is available for conduction of electricity. And that is why graphite conducts electricity. The electron that is not used in forming bonding is called free mobile electron or delocalized electron. Then graphite is also formed when coke is heated to a very high temperature in an electric furnace. This process is called Hutchinson principle or Hutchinson process. These shell diagrams will show you how each carbon atom is bonded to 3 other carbon atoms in graphite. You can see this is a carbon atom having 4 electrons in its outermost shell. 1, 2, 3, 4. So it will donate 3 electrons, and each other carbon atom will share the 3 electrons with it, and the 1 electron and the other electron from its own self with it. It's as shown here. So this electron was donated by this carbon atom, so the two are shared between them. At the end of the day, we have 1 electron that is not used in bonding, which is called the localized electron, and that is used in conducting electricity. What are the properties of graphite? Graphite is soft and greasy to feel. It has a density of 2.3 grams per cubic centimeter, less dense than diamond. Has a high melting point of 3,500 degrees Celsius, but not as high as that of a diamond. It conducts heat and electricity, as we have said. This due to the presence of mobile electron in its structure. Like diamond, graphite does not also dissolve in any known solvent, but in its own case it is black and opaque, and it is in form of hexagonal plates. What is diamond used for? It is used as lubricant. This is because it is soft and one layer of it slides over the other layer, just like we have it in liquids. But it is better than any liquid lubricant because it does not evaporate. It is in solid form, so it is not volatile. It is resistant to heat. It does not wet the substance between which it is serving as a lubricant, and it's also insoluble. All this imparts great advantage to graphite when used as solvents, as a lubricant, rather than using any liquid lubricant. Because it conducts electricity, it's also used in electrolysis as electrode and as brushes in electric motors. Also, because it flakes, that is, when rubbed against a hard surface, it leaves a mark on the surface. Part of it can easily be peeled off. It is used in lead, what we call lead in pencil. What we actually call lead in pencil is made up of a mixture of graphite and clay. In that lead, clay imparts hardness, while graphite imparts softness. The higher the percentage of clay in the lead, so-called lead in pencil, the harder the pencil is. So, and that's why we have hard pencil and soft pencil. Those ones that are called hard pencils are made up of higher percentage of clay. Those ones that are called soft pencil are made up of higher percentage of graphite. Also, because graphite has high melting point, it is used in making crucibles. The crucibles we used in the laboratory. And because of its color, it is used in making the black pigments in paints. Especially when you want to make black paints, graphite will come handy. It's also used in nuclear reactors. A nuclear reactor is an equipment where a nuclear reaction is allowed or is made to take place at a steady, controlled pace. Graphite is used. This is because of its softness and high melting point. Because however the temperature rises, graphite will still remain solid. This is where we are going to end today's lesson. I beseech you to check your portal for your assignments, solve the questions, and submit. May Allah grant us all perfect understanding. Assalamu